In the grand theater of evolution, there are specialists, and then there are the absolute outliers. Most birds looked at the sky and saw freedom. The penguin looked at the freezing, high-pressure depths of the Southern Ocean and saw an opportunity. Over 60 million years, they didn't just lose the ability to fly, they traded it for a suite of biological superpowers that seem like something out of a sci-fi novel. Imagine a creature that endures temperatures that would shatter human steel and dives into a darkness so deep the water pressure would crush a standard scuba tank. We aren't just looking at a cute bird in a suit. We are looking at a biological submarine, a thermodynamic marvel, and arguably the most successful specialized hunter on the planet. Today, we're going beyond the waddle to look at the extreme engineering that makes these animals the undisputed kings of the Southern Hemisphere. We've all heard about the tuxedo, the classic countershading. It's nature's perfect cloaking device. White bellies to vanish against the sky for predators below, and black backs to disappear into the dark depths for predators above. But the real genius is in the fabric. Penguins have the densest feather coverage of any bird, up to 100 feathers per square inch. These aren't just feathers, they're overlapping shingles. But here's the secret. It's all about the oil. At the base of their tail lies the uropygial gland, the preen gland. The penguin uses its beak to spread this specialized hydrophobic oil across every single feather. This creates a molecular seal that is 100% waterproof. Underneath this shield, they trap a layer of air that acts as a high-grade insulation vest, keeping their core temperature at a steady 100 degrees Fahrenheit, even in a -60-degree gale. But wait, there's more. When a penguin is underwater and needs a burst of speed to escape a leopard seal, it releases that trapped air from its feathers. This creates a coat of tiny bubbles that drastically reduces the friction between the penguin's body and the water. This process, called air lubrication, allows them to double or even triple their speed in seconds, literally shooting out of the water and onto the ice like a feathered missile. Most birds are built for lightness, utilizing hollow, air-filled bones. But for a diver, air is the enemy. It makes you buoyant. To solve this, penguins evolved heavy, solid bones that act like a lead weight belt, allowing them to achieve neutral buoyancy. But that's only half the battle. How do they stay down for 20 minutes on a single breath? The answer is in their chemistry. Humans are lung breathers, but penguins are muscle breathers. They possess massive amounts of myoglobin, a protein that binds oxygen directly into the muscle tissue. This turns their meat a dark, almost black color because it is so saturated with oxygen. While they're submerged, they perform a feat of biological management called the dive reflex. Their heart rate drops from a frantic 200 beats per minute down to a mere 20. They effectively unplug the blood flow to their digestive system, kidneys, and flippers, shunting every oxygen-rich drop of blood exclusively to the brain and heart. They are essentially living in a state of calculated suffocation. And to survive the crushing pressure of the deep, they've mastered a trick that would kill a human. They voluntarily collapse their lungs before a deep dive. This pushes all the air out of the lungs and into the upper respiratory tract, preventing nitrogen from entering the blood and stopping the bends before it even starts. On land, the enemy shifts from pressure to cold. In the Antarctic interior, wind chills can hit a staggering -80 degrees. No single animal, no matter how thick its blubber, can survive that alone. This led to the evolution of the huddle, which is less of a group of birds and more of a superorganism. Physicists have studied these huddles and found they move with mathematical precision. To prevent the birds on the outside from freezing, the huddle is in a state of constant, slow-motion flux. Every 30 to 60 seconds, a pulse or wave of movement travels through the huddle. Each bird takes a small step, just about 2 inches, and this collective shifting slowly cycles the cold birds from the windward edge into the warm, protected core. Inside that core, the temperature can reach a sweltering 100 degrees Fahrenheit. It gets so hot that you'll actually see clouds of steam rising from the center, and birds will periodically break the huddle just to eat snow and cool their core temperature. They have successfully used social cooperation to create a portable, self-sustaining tropical microclimate in the middle of a polar desert. Imagine living in a world where every drop of water you drink is saltier than blood. For us, drinking salt water leads to rapid dehydration and organ failure. But penguins are built-in desalination plants. They possess a supraorbital gland located in a groove in their skull just above the eye. This gland filters excess salt from the blood and concentrates it into a briny liquid that they literally sneeze out of their nostrils. And their vision? It's equally specialized. Most birds have a curved cornea to focus light in the air. But because water has a different refractive index, air-focused eyes become far-sighted underwater. Penguins evolved a remarkably flat cornea, allowing them to see with pin-sharp focus while chasing agile fish in the dark ocean. Back on land, they have a one-way digestive system. Since they don't have teeth, they have evolved papillae, backward-facing, fleshy spikes that line their tongue and the roof of their mouth. These act like a biological conveyor belt. Once a fish is gripped, any attempt to struggle only pushes it further down the throat. There is no spitting it out. It's a one-way trip to a stomach that can even pause digestion to keep food fresh for their chicks for days at a time. Finally, let's talk about the waddle. We laugh at it because it looks inefficient, but it's actually a masterpiece of energy conservation. Because penguins have such short legs and heavy bodies, walking normally would be exhausting. Instead, they use a side-to-side gait that mimics a pendulum. As they rock, they store energy in their tendons and muscles at the top of the swing and release it on the way down. This pendulum motion allows them to recover up to 80% of the energy they put into every step. For a bird that might have to walk 70 miles across the ice to reach a nesting site, this efficiency is the difference between life and death. When they get tired of walking, they toboggan, sliding on their bellies and using their flippers like oars. It's the ultimate energy-saving hack.